All right, so I think we made it. This will be the last set of new videos for the semester before we start just reviewing a bunch and kind of remembering all the stuff that we've learned throughout the year and kind of making sure that we have practiced everything. So the last thing we're going to talk about is finding volumes. All right, so when we were talking about all this integral stuff for the second part of the class, we've been finding areas under a region. I've been finding a lot of area ones. And now we're just going to shift our focus for this set of videos to volumes. So volumes are just taking this 2D thing and making it 3D. So it's really one of the major topics that we'll cover in this class that involves 3 dimensions. All right, when we're working with 2 dimensions, we're finding our areas. All right, we had something like this, and we made a bunch of rectangles to approximate the area, and that led us to this integral sign and antiderivatives and all that. So you might think when we're talking about a volume, we want to use a box because that's kind of the 3-dimensional version of a rectangle. But based on the areas that we're trying to find, we're going to be doing something called revolutions, which is when you're turning something. So instead of boxes, we're actually going to use little cylinders. All right, so cylinders is what we're going to use to approximate these volumes, and that'll lead us to our integral definition and all of that. All right, so how do we find the area of a normal cylinder? Again, a cylinder is just a circle with some height, basically. All right, how do we find the volume of this cylinder? And I put area, this should be volume. All right, the way we find the volume of this cylinder is basically find the area of the base. So what is the area of this circle? It's pi r squared. And then we multiply it by the height, which is h. All right, so that's how we find the volume of a normal cylinder with this kind of constant radius. All right, it's fairly straightforward. It's just a formula that you use. But what happens if we want to find the volume of this thing? It's kind of cylindrical in the fact that it's a bunch of circles, right? It has a circle down here. Let's see, different color. All right, a circle down here as one end, and it has this circle up here as another end. All right, so there's some cylinder stuff going on, all right, but it's not exactly just a single cylinder. We can't just use exactly that formula from the last slide. Right. But the basic idea is, like I said, we're going to approximate it with cylinders. We're going to think about a little cylinder here. We're going to add to it another little cylinder right after it, and another little cylinder. It's really hard to draw in 3 dimensions, but you get the idea. Is that we're basically going to stack these cylinders that might all slightly over approximate or under approximate the volume. But this is the exact same thing that we did with rectangles and area. So the basic idea is that it's going to give us an integral that'll give us the volume. All right, and this is what the formula is going to look like. And this is a topic that seemed really complicated when I was doing it in school, but the basic idea is this. You have this function, and we'll try to mimic the one from the last slide. It looks like this. You're going to rotate that function over the x-axis. When I rotate it, I get this circle here. I rotate this end piece, I get this circle here, and that gives me my cylinder that we had on the last slide. And how do you find the volume of a cylinder? Well, it's pi r squared times the height. All right, well, the only difference between a normal cylinder and this, instead of having just a constant r, our radius is given by the height of the function. All right, so that's this curve here. So that's why r is getting replaced by whatever the function is that's giving me the radius of my cylinder. All right, the pi is there because pi r squared is the area of the cylinder. And the integral part is basically the height part. It's what's happening in this direction. So as I go from A to B, my radius is changing. I mean, I'm getting all these different areas for different cylinders. And then, again, the integral part basically adds up all these small cylinders together and gives me the actual volume. And it keeps actually accidentally saying area when I mean volume. But I was trying to find volumes here. So this basically gives us a bunch of little volumes added together, and we put them together. So really all you have to know is that pi r squared is the area of a circle. The integral adds up all these circles together to give you a volume. All right, so that's the basic idea when you're finding the volume of this thing that's revolved around, and it basically makes a bunch of circles.